Hello, and welcome back to Political Science 4781, Techniques of Political Analysis. In the last video, we talked a bit about APIs, what they are, and how they're used. And we talked about the fact that they really make it very straightforward for people who are interested in either obtaining or analyzing data to hook into other programs in order to do that, or other websites. Today, we're going to talk about some real-life examples of how you can use APIs in R. Okay, so what I want to do is start with the more straightforward APIs and show you how they can be used, and then move down to the ones that are a bit more difficult and more challenging. The most clearly straightforward is the World Bank's World Development Indicators, which, as I mentioned, can be obtained through a library in R called WDI. So once you've loaded WDI, you just use the WDI search command with any string to see what variables there are in the data set that contain that string. And if you scroll back up to the top, what you see is, now GDP gets used a lot, right? Because a lot of things are, it's percentage of GDP and so on and so forth. But you also get, GDP per capita measured a bunch of different ways, growth in GDP per capita, and so on and so forth, right? So once you've found, let's say we want GDP per capita in current US dollars, this is on line 93. So we go up here to where the names of the indicators are. We find line 93, and we see ny.gdp.pcap.cd. Okay, that is how the World Bank internally references that indicator, and that's the main thing that you need to keep in mind for the next command. So what you do is you create a data frame basically out of just the indicators that you're interested in. So in order to do that, you create a data frame. We're going to call it my data. Again, I'm not terribly creative when it comes to these examples, I'm afraid. We'll use the WDI command. We're going to tell it all countries. And this will actually give us a list of countries and aggregates, like the European Union and the world and so on and so forth. We'll deal with that in a moment. And then we tell it, all right, I want three indicators here. I want life expectancy, and that is sp.dyn.le00.in. That's our life expectancy indicator, our total population indicator, and our per capita GDP indicator. Extra equals true just gives us a bunch of extra information about each of these countries, which can be useful for graphing them or for any number of other things. We start in 1960 and we end in 2012. All right, so we do this command. We wait a little bit because it has to go bug the World Bank and get the World Bank's computers to respond to it and feed it data. But once we've managed to do that, I feel like I should have Jeopardy music playing in the background. Okay, here we go. Once we manage to do that, we use the head command to see the beginning of first few lines of each indicator. We've got country. Now this is an aggregate, the Arab world. We've got year. We've got life expectancy, total population, per capita GDP, the 3-letter ISO code, the region, in some cases where it's relevant, capital, latitude, longitude, income, and lending figures. So you get a lot of information all wrapped up nice and neat in a tidy data frame with very little effort. Now, if you want to get rid of the aggregates, let's say you want to do something like the Hans Rosling graph, and you don't want a giant world bubble sitting there next to the China and the India bubbles, which makes a lot of sense. You just use this command. You create a subset of my data where the region does not equal aggregates. Okay? So when you do that, then you take a look at the data. You see, all right, the first country is Andorra. The region is Europe and Central Asia. So, and here's the capital, latitude, longitude, So, this gives us what we're looking for in terms of WDI data. And as I say, the range of data that are available from the World Bank is really quite staggering. So, if you're thinking about, especially anything having to do with economic or demographic data, you should definitely check the WDI library first, because it's one of the best places to find it. You can download the data almost instantaneously. Okay, another really handy API to know about, Google's geocoding capabilities, which for some reason I wasn't able to. Okay, so we load ggmap. It's the package that contains the command that makes this easiest to use. And we use the geocode command. Okay? And we tell it, I would like you to give me the latitude and the longitude for Ohio State University. That's what that means. We create an object called test, and that's going to contain the geocoded information for the Ohio State University. Now, Google Maps is pretty smart. It uses the same interface that Google Maps does. So you don't have to give it a city necessarily. You don't have, anything that Google Maps can recognize and pinpoint, this API is going to be able to recognize and pinpoint. So it tells us the Ohio State University has a longitude of negative 83 point blah, 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 latitude of 40 point blah, blah, blah. Okay? Now, if you needed to look up, let's say we want to look up the 10 largest cities in the world, which, and there are about, I think, as many different ways of measuring what large cities are as there are cities on this list, but we'll go with this list. Okay, Tokyo, Japan, New York, U.S., Sao Paulo, Brazil, so on and so forth. Okay, so first you create a vector that contains all of these names. Okay. And let's just take a look at it, and sure enough, here's our vector with all of these names listed, right, as text. And then you create a new data frame. Actually, it's just a vector with I think it becomes we will see. I think it's a data frame. All you do is tell it, please geocode this vector of large cities, okay, and it will come out with the following little data frame with latitude and longitude. And if you create a new data frame by just sticking these two together, right? You don't need to merge because you know that they're in the same order. So you can just create a data frame with the vector of largest cities and the vector of the data frame of locations. Then, if you take a look at that, right? You've got your city, and for each city, the longitude and the latitude. The titles are a little bit ugly. We can add column names here. City, longitude, and latitude, so that when we enter this, we get a nice tidy data frame with city and longitude and latitude. This is really cool. Sometimes you end up with a data set that you want to plot on a map, and the data set includes the names of places, but it doesn't really include any latitude or longitude information. Under those circumstances, Google's geocoding API is a lifesaver. It really does an amazing job of pulling down latitudes and longitudes really quickly. It's limited. You can only get a certain number of geocodings per day from a given computer, and they keep track. It's I think it's in the hundreds, if not the thousands. I mean, it's probably a higher limit than any of us would be likely to run into in sort of normal day-to-day use. It's meant to make sure that nobody abuses the system and completely overwhelms Google's latitude and longitude lookup service. Okay, so that is geocoding. Last thing I want to talk about is a kind of API that produces data, and this is actually fairly common. It's one of the most common kinds of APIs that produces data in JSON format, JSON. And JSON format looks like this. This is an up-to-date API that lists drone strikes by the U.S. primarily in Pakistan and Yemen. And it contains a lot of information. This is the country where it happened. This is the date, if possible, the town, minimum and maximum deaths. They rely on journalist reports and some from the Bureau of Investigative Journalists, and it contains even the sort of a short summary of what happened during the strike, as well as a link for more details if you want to look it up, and happily enough, latitude and longitude. And if there are any people specifically mentioned in the report, it lists those names. So this is actually a pretty impressive amount of information. The problem is that it's not in a format like CSV that R sort of reads in natively. So for the most part, what you need to do when this happens, there are libraries, RJSON and RJSONio, for example, that will allow you to read in data from a JSON or JSON data stream or API. The problem is that they tend to read them in the form of lists rather than data frames, which can, depending on the source, depending on the list, it can be rather difficult to convert them into data frames. So what I've done is I've gone sort of Googling around to find out how it is that that you convert these drone strike data into a data frame, and happily I found this website, bretterblog.wordpress.com, which has a great entry on obtaining and mapping drone strike data. The Google Fusion Tables part I didn't borrow, but I definitely borrowed heavily from the part on importing JSON data. So we start by using the package rcurl, which just gives R the ability to do the Unix curl command, which is a way of accessing internet information off the internet, and the RJSON library. And we do this command. First we're going to create a JSON representation, or a list representation, I think, of the drone feed data. We're going to use getURL, which is from the rcurl library, and suck all of this information down using the from JSON command. Okay, and that's going to take a moment. Now, that, if we just look at drone feed right now, it doesn't look all that helpful. This is what a list looks like in memory in R, and unfortunately it's not as straightforward for us to use as a data frame, so it makes a lot of sense to convert it to a data frame first. Now, how do you go about converting it to a data frame? Trial and error to some extent. You have to, really the first best solution is to find someone else who's done it first. But I can show you a couple of things that are being done in here. These double brackets are referring to nested parts of a list. This tries to prevent the strings from being turned into factors. It ends up not working at all. Actually, this I think this first command, it transposes. Looks like it creates an empty data set. Yeah, it does. As a matter of fact, it creates an empty data frame. Right. So this is what we're going to be putting the drone data into. And before we do that, we're going to be creating names for the empty data frame from the drone feed strike name list. So, okay, we've got the ID number, the country, the date, the town, and the location. So this is an entirely empty data frame that's set up. Now, what the bright folks at bretterblog.wordpress.com have done is they've created what's called a for loop. This is a bit complicated. For loops are programmers' tools. They basically say take a variable I and start counting. Start at 1 and finish when you get to the end of the drone feed strike list. So it's going to be something like from 1 to 502, I think is the way it looks from here. And then essentially what this does is it creates, if there are empty or useless entries in this feed, it just fills them in with 0. Okay, so that's what these two lines do. Whoops, I'm sorry. You have to do that within the for statement. Then this final line here, right, will fill in the drone strike data from the drone feed. So we execute all of these at the same time because the for command starts here with this curly brace and ends here with this curly brace. And we now have something different in the drone data set, right, which is a whole bunch of stuff. We can actually be a little more, right? So we do head drone data, and we'll get a quick look, right, that we've got an ID number, a strike number, the country, the date, the town, the location, number of deaths, minimum deaths, maximum deaths. Some of these are kind of annoying because, civilians 3 to 8. It's more useful to me to have that in 2 separate columns like this, deaths minimum and deaths maximum, so that I can, decide whether to use the minimum, the maximum, the average, whatever. There's a, I don't know if they're tweeting it or if it was tweeted somewhere else, but I think the drone stream people are tweeting every one of these. And then here are the short summaries from the Bureau of Investigative Journalists and the links and the latitude and longitude, importantly, right? And finally, the names. So you would think that a lot of these things that look like numbers are in fact numbers, but one of the things you learn using R is sort of trust but verify. So if we take a look at drone data $lat right here, which looks like a number, we find out it's actually a character, which is a real pain. So what we're going to do, we're going to convert date over to date format. Okay, we know where the date is. There we go, and it's not exactly what we want for R, since R doesn't understand every kind of date format. We're going to convert it over to R's internal date format. We're going to convert latitude, longitude, maximum and minimum deaths from character to numeric. Okay, so we're going to do all those things just to clean up the formatting of the data. And then when we do a summary, we'll see deaths minimum, deaths maximum. They have minimum, median, mean, maximum. So these are actual concrete numbers. Okay, and we're going to create a new variable, deaths average. So we don't really know if it says it's between 6 and 8 people. How many people? If you wanted to do a graph of how many people were killed, and the number of people killed were sort of between 6 and 8, what number would you pick? Well, the odds are that you would pick something like 7, right? Unless you specifically wanted to focus on the maximum number who may have been killed or the minimum number who were killed. But, to be fair, your best guess is probably around 7. So we're going to create a deaths average variable that's just maximum plus minimum divided by 2. Okay. Now, once we've done that, we'll create a new data frame that has only the information that we actually care about. That is a lot of this stuff, the Bureau of Investigative Journalists link, the summary. For the moment, we're not going to focus on those, so we're going to create a third data frame called drone that just has the date, average deaths, the country, the latitude, the longitude. Okay. Now, and we're going to give it some column names that are considerably easier to remember. So if we look at our new slimmed down data set, we just have date, average number of deaths between minimum and maximum, the country, the latitude, the longitude. Okay. Now, we can plot these, and there are, I should note, I criticized a different visualization earlier on in this class because it paid attention to the number of children it paid attention to the number of children and the number of civilians, but it didn't pay attention to the number of militants who were killed. And this data set, annoyingly enough, suffers from the same shortcomings. So we have strike number 172 in Pakistan, 6 deaths. We're pretty sure that it's 6. There are no civilians. There are no children. 6 alleged militants were killed in an attack on a car. But we don't have any field here for militants, right? The only thing we know is how many people died, how many were civilians, how many were children. We could infer that everybody who isn't a civilian or a children or a child rather is a militant, but that's pretty questionable because you actually see a lot of these cases where you've got 2 civilians, 2 children, and 18 people total killed. But the summary doesn't indicate that the remaining 14 people were militants, right? So really, ideally, what you would like is to contact the person who makes a list and say, hey, is there any way that you could modify this so that it also has, you're obviously getting the information about children and about civilians. Could you also get the information about militants while you're doing it? I have done that multiple times to no avail. It seems to me that the person who came up with the drone stream list and if you look at his Twitter stream, it's very clear he's much more interested in focusing on the deaths of civilians and children than he is in focusing on the deaths of militants. That's, whatever, it's understandable. But unfortunately for us, trying to come up with a really objective picture of what it is that the drone strikes are doing, it's not as complete as it could be. So I don't want to get into, at the moment, sort of plotting the number of civilian deaths versus children versus other, because I don't think it's a very going back to the lecture about truth. I don't think it's really a completely unbiased representation. And I would say the same thing if it only had information about the deaths of militants and not the deaths of children. Right? I think one of the things that we need to try very hard to do is to maintain a degree of fairness in what we do. But we can take a look at the number of drone strikes over time. Okay, that's an interesting datum. And as we can see, here are the Bush years and here are the Obama years, and the man likes drones. That is pretty clear right away from the plot. We can also, excuse me, we can specify that we only want to look at dates and deaths when country is equal to Pakistan. Okay, again, we use the brackets here. This bracketed phrase or term at the end here to indicate a condition that we need to have be true if we're going to use a particular observation. So what this says is, give me the list of dates for strikes in Pakistan. And here it says, give me the number of deaths for strikes in Pakistan, and only strikes in Pakistan. Make the color blue. Type H, which is this histogram plot that you see here. We're going to X label date, Y label deaths, and the main is going to be U.S. drone strikes. Okay, so here in blue are the drone strikes in Pakistan. Now we can add lines to this for the drone strikes that are in Yemen. Okay, and again, all we have to do is the same thing. Give me the date and the deaths for all the drone strikes that are in Yemen. Make the color red this time, and the same type H to indicate that we want the histogram. So what that does is it plots the Yemen drone strikes alongside with, or in some possibly over, but it doesn't look like there's too much danger of that, the Pakistan strikes. And then finally we can do the same with Somalia. There are not many strikes in Somalia, but we can color them green to separate them from the other two. Okay? And you can see down here just a few little green drone strikes in late 2011. And then finally, once we've done all this and we want to give our readers a legend, we can put a legend up in the top right that shows us blue line for Pakistan, red line for Yemen, and a green line for Somalia. So that is a pretty straightforward example, although with JSON data, getting the data into a data frame format is anything but straightforward. It can be a real exercise in frustration, and it definitely falls into the kind of advanced R user category. My strong recommendation, as I've said multiple times in this lecture, is to find somebody who's already done it and basically steal what they've done. People in the R community are incredibly gracious about sharing their code. So if you find something in JSON format, it can be a bit of a pain to download and get into a format in which you can use it. But there are other formats out there that are much more straightforward to use, including those that are already built into existing libraries for R, or those that allow you to access them very quickly and easily using existing packages, or the ones that, like the earthquake data from the previous lecture, are just laid out on the internet in comma separated value format so that you can just go out there and download them.